Okay, today we're going to take a slight excursion from data structures and learn the STL. This is the standard template library. It's a library provided for all C++ programs. So it is built into the language. This is actually a spec of the language. So if you have a C++ compiler, you are supposed to have this. That's important to keep in mind because other libraries are usually bolt-on and you have to download them, which isn't a bad thing. But do note that if you can use anything inside the STL, please do so because they've spent a lot of time optimizing it and of course making it correct. Also, after today, I highly recommend you never use your array or singly linked list class, not because it's terrible code, I mean, it probably is, but because, again, let's just use the library which people have worked on. Okay, so STL, it contains, they divide the STL into three different categories: containers, algorithms, and iterators. So containers are effectively our data structures, arrays, linked list. There is a heap, there is a binary tree as well. Algorithms are just standard, search, binary search, etc. All those different ones. And then iterators, we haven't talked about iterators too much in this class. Kind of, defeats the purpose of learning certain things, but we'll go over them today. They can be frustrating in C++ at first, but once you get the idea behind them, they're easy to use. They're just not exactly intuitive at first. Okay, perfect. Because y'all did iterators in OOP, right? Iterator begin, no? Maybe not? Yes, you did. Okay, good. Whew. So here's the picture. Oh, I got cut off. So algorithms will use iterators to interact with objects. Hey, look at that. So containers, that's your data structure containing objects. An algorithm, say find, will use an iterator to go through a container to find something, or for each, or whatever you need. And that's the idea. Everyone got this perfectly?
Yeah.
Yes. Yes. We'll get to code, don't worry. All right, common containers. There are more containers than these, but these are probably the ones you're going to be using the most in this class. Vector, that's your one-dimensional array. List is a doubly linked list. I don't think there's a singly linked. DQ, double-ended queue, so you're going to pop and push to the front and the end. You got a queue, regular queue, just push and pop. Stack, a set. We'll get to sets in a moment. Set is when you're just saying, I have these elements. Does this element exist in the set? And then a map is an associative array, which we will get to later, also known as hash tables, if you did that in OOP or Java. Did you call them hash maps or hash tables? I forget.
Hash maps.
Hash maps, that's right. Okay. This part's not too important, but do keep in mind that C++ does delineate between the different types of containers. So a sequence container stores it in sequential order. Notice that a binary tree doesn't exactly store things sequentially, but our list and our array did, and they just keep that as a tag or piece of information. That's nice. Associative array, this is where you have a key value pair. We're going to do this a little more, also called a dictionary in other languages. So the idea here is you're associating a key with a value. You kind of already do this within a regular array, except for the key has to be an integer at all times because you're using the integer to index into the array. So you have an int and then you get back the value by passing in the int. In a fully associative array, because it's templated, it doesn't have to be an integer going in, it can be whatever. And we'll get to more of that later on in the course when we do hash tables. That's great. Only important part here is that a set and a map by default can only hold one element or one instance of it. So if you're having a set of numbers and you pass in 10 twice, it only stores 10 once. But if you want to store multiple of them, you use a multi-set or a multi-map. Good, now let's go to code. Now let's just jump over. Where are we? CP, we did the heap, beautiful. Let's do the STL. Alright, and since we're I mean definitely just exploring things, we're not going to be testing. So let me get rid of these tests. Oh, hey, look at that. Alright, so we'll get a vector of int. And hey, how do they do it? Oh, so they create the vector that way. Perfect. I'm going to call it vec. And we'll pass in an array that we haven't created followed by 5. Alright, there, I got your number. Any other numbers? Got to do 4 more. Oh, 4 more, so 5 in total. The Space Odyssey? Oh. 2001 The Space Odyssey? That's what I was saying. Or do people not watch that movie anymore? Ooh.
I read the book.
Read the book? Well, it has the... What's that?
I still haven't seen that.
Yeah, I guess people would, this university wouldn't like the intro to that movie that much. But yes, it has the classic music at the beginning. Anyways, the giant monolith. Sorry, the monkeys touched the monolith. I have knowledge now! Whew, all right. All right, where are we? Vector. Okay, so there's different ways to iterate through this vector. So we can do int I equals 0, I is less than vec.size, I plus plus. Oh, something. What did I mess up?
The 9.
Ah, the 9.
And we don't have a size, right? Wait, no.
Yes, we do. I mean, there's size and capacity. So size is, yeah. So we're on vec. Sorry. Let's put a space in there. And then backslash n. All right, great. So let's, can we make this? No. Oh, yes. All right. Sure, we'll still do it. Whew! And this is why, excuse me, the STL is annoying, because you fix one error and then you get more. No matching function call for int5id. Oh, cool. Let's see. Isn't that what they did? Oh, that's right. Because when you pass it, you pass the beginning of it and the end of it. You don't pass the size of it. All right. And why would they do that? Well, we'll get to that in a bit. They have a very good reason for that. Then it runs files with no problem. Hey, there's our numbers. All right, great. So let's jump over here. What do they do? Well, push back and push front. Okay, sure. Why not? I'm going to make a function because I don't want to do it anymore. Print vec vector sub ints. Blah, 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 blah. We'll make it a reference. Let's see if I typed that correctly. Nope. Alright, there. We made a separate function, so our lives will be easier. Alright, so we do vec dot pop back, and then we print afterwards. We should see 42, 51, 71, 81, because we got rid of the last one for us. Hey, look at that. And then if we jump over here, and then we push back, what are we pushing? Now we're going to push 2001 there. And there's 2001. All right. It's Monday, so quick, easy, getting back into it. Hopefully, wait, hold on, I'm sorry. I said that too soon. Everyone doing well?
Yeah.
All right, now insert what I just said. Okay. All right, so, hey look, v.begin is pointing, is pointing here. Let's see what v.begin actually is. It's a giant error. All right. I was really hoping it'd be a lot easier than this.
You have to do the dereference thing, right?
Yes, you do.
Okay.
But is that obvious from what just happened? Not at all. Oh, man. All right. So, yeah, you have to dereference it. I'm going to dereference it like this just for emphasis. Because it's a pointer, well, it's not actually a pointer, but it behaves like a pointer. And there it is. Whew. Okay.
We definitely know that that's the answer.
Yes. Yes. Okay. Well, if that's begin, what do you think end is? I wonder if it's, ooh.
2001 or 20. No.
Oh, it did it. Okay. Whew. Well, that's kind of weird. What if we pop the back before we ask for end? Can you give me 2001? Yes. So I pop the back, it gives me 2001. So if I don't pop the back, and I'm at this situation where I've popped the 20 and then pushed 2001, by the way, pop back doesn't actually delete it, it just decrements the size up, but hopefully that's intuitive. So then what's vec.end?
Where 20 used to be.
But 20 was overridden with 2001.
No.
So if I pop the back here, then vec.end is 2001, which means it's pointing to 1 after the last element. So vec.end always points to 1 after the last element. Why would you do this? Well, let's see if the slides show us real quick, otherwise I will show you. That's not what I want. It's not going to show us. Okay, well then I'll show you. 4. All right. I'm going to try this. Usually this fails. I went in autopilot. Create an iterator I that starts at vector.begin. While it's not at the end, increment I. Iterators in C++ behave like pointers. So you dereference it in order to get the value. And then we'll do cout \n. All right, if I type that correctly, whew, I did. Okay, good. Hey, look, it printed the same thing. All right, now let's think about this for a while. We have 2 versions up here. Which one do you prefer?
First one.
The first one. Anyone prefer the second one?
Is the second one faster? Is
The second one faster.
Because
I-
tiny bit, right? Because it's like the iterator, you can just do next instead of having to do the operator, which goes from the beginning. But it's coming out difference.
Welcome to you.
Oh, I do prefer the first one.
I will say the second one can only be slower, but if
Yeah.
coded correctly, the second one is just as fast as the first. As long as you turn optimizations on, sorry. As long as you turn on optimizations. Now, if you don't turn on optimizations, it depends on the situation due to how the compiler generates code, which one will be faster. But with optimization, basic optimizations, the first one is always at least as fast as the second one, if not faster.
Wouldn't for linked list the second one would be faster?
Yes.
Okay.
Yeah. Does the second one actually depend on what vect is? Like, could vect actually be a list? And would the code still work?
Yeah.
Yeah. Would the code really work on the first one? By the way, list does, yeah, no, because list doesn't have the subscript operator. In other words, the reason why C++ prefers this version is because as long as you implement begin and end inside of your, begin, end, and your construct or your iterator can be incremented and dereferenced. You implement those 4 operations, this will work. And independent of what the data structure actually is. So I'm going to go ahead and comment out version 1, because in C++, when you use the STL, you are supposed to use this. I'm also going to make our lives easier and tell you right now, please just do this.
I've had to do that one already.
Right, because I've used C++ for so long, I knew what to type. It gets really, really complicated because we haven't talked about the fact that you can put vectors inside of vectors or lists inside of vectors and start nesting them. And then that becomes just a nightmare to type out. On the flip side, please be careful when you use auto. Auto should be something you use really not so much sparingly, but only when it makes a lot of sense. You have an iterator. Okay, obviously that's just an iterator. You don't need to type that out. But a lot of people will use auto all over the place when losing the data type. Really hurts the reader. There we go. Who's trying to read your code. Just a warning. But that unfortunately only comes with experience. I can't really make you do it right now. Oh well. Okay, so we talked about auto. Let me recompile and run just to make sure it all works. We're still good on that. All right. Let's jump back to the slides. All right, so that was one way to print it, and we did that. And I think we're pretty used to the fact that we can do subscript and set the variables or values. Okay. So yeah, we'll go ahead and do this real quick, sure. And I'll make it a function. I'll call it drain vector. So this is going to drain it, get rid of all the elements. So what do we do here? Well, while not vec.empty, we'll do standard cout. We'll print the you want us vec.back. Ooh, is this a function or not? I always forget. It's a function. And then we'll pop the back. So that'll hopefully drain it. It drained it in reverse. Hey, we should put in a new line. And there's a new line to make it look easier. Why did it print in reverse?
Because you start at the back.
We start at the back, okay. And just to make sure we're all on the same page, vec.size equals and then we'll also look at capacity. Hey, what's capacity going to be?
5.
Oh, we've got some 5s, all right. Huh, yeah, you're right. It could have been something else, but it was 5. All right, how are we doing?
Not awful.
Not awful. Well, yes, a vector can be of other things. You can make it of dates, integers, floats, students, anything you want to do.
I mean, we could go back and dig up those Pokemon.
Pick up the Pokemon. So yeah, for vector, so the first one creates 1,000 of them using the default constructor. The second one creates 10 of them where you pass in the basically the template of the instance you want to have copied to each one. And then the last one initializes one vector y with vector x. Hey, it does a deep copy. Ooh, excuse me. Just like we've been doing the whole time. All right, we'll skip that. Iterators, okay. Now they're gonna start talking about iterators. I just showed you what they were, but let's go ahead and do them again. Iterators are pointer-like. Again, they behave like pointers. They are not actually pointers, they just behave like pointers. Oh, okay, yeah. Are used to access individual elements in a container. Often they're used to move sequentially from one element to the next. Whew. A process called iterating, okay, through a container. So you might have an iterator pointing to one of these and it can move through. Beautiful. Here we go. v.begin points to the first one. v.end points to one after the last. And I kind of don't like this picture because it looks like size should be where v.end is pointing, but it points to one after the last. Oh yes, you can have all the iterators you want. You can have multiple iterators going through a container. Sure. You have one going from the beginning, the other going from the back. They can bounce around. Yeah. Whatever you want. All right. So here we go. v.begin points to the start. v.end points to one after the last. Does it now make sense why when we did the vector constructor, we passed in array and then array plus 5? Right. Because now you can just pass in a vector or an iterator from beginning to end, and you're done. And now it works with both regular C arrays as well as STL containers. Same function. They didn't have to rewrite it. All right.
Convenient.
That's it. Oh, we got. I really just want to say, any questions? Elena, you have my exact expression on this subject. Have you all learned the STL on your own a little bit, or maybe a little? Okay.
For like the projects and labs.
Well, this is what's going on. All right. Begins. Oh, dereferenced at the start. Great. Well, start does not equal stop. The stop. All right. If it's greater than, you update it. Otherwise, increment and then return at the end. It's just max. Okay. All right. I think we showed that where you just have to dereference it because it behaves just like a pointer. Beautiful. If I'm going too fast, stop me. C++ does like to categorize your iterators. Really, we just need to know about bidirectional and random access. Most of the time, you'll be using bidirectional iterators. But you can't always iterate in both directions. This may not seem intuitive at first, but if you're reading from the keyboard, you can't read past the keyboard because you already pushed the button. Similarly, if you're writing to a screen, you can't write to the past, you can only write forward. So there are instances where you can only have input or output. Yeah, usually they're forward. Bidirectional, array, linked list, you can go both directions. Random access, this in general only applies to arrays, either our regular vector or the map. Otherwise, everything's going to be essentially bidirectional. All right, why do we do this? Well, we can do a for each. Hey, look at this. Sure, we'll do that. Whoops. Print me. Okay, in order to use algorithms, you do have to include the algorithm, there we go, header, and then down here you do for each, vec.begin, vec.end, and then you pass in the function you want to call, and if I type that correctly, it'll work. I did maybe? Oh, yes, because I totally did it after we emptied it, so obviously it wouldn't print anything. Hooray! Okay.
That poor last guy in the list.
The last guy in the list?
Yeah.
Alright. So hey, look, there's for. Did y'all do for each in OOP in Java? Nope. Alright, for each is becoming very popular for various reasons. First off, you don't have to do for in I blah 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 blah. You just for each, which is a little more intuitive in what's going on. But also, what's happening, C++ doesn't do this, but the idea is that eventually we'll get to the point where when you call for each, you can assign a core to every iteration and then do that for each fully in parallel, as long as they don't, the iterations don't depend on one another. Because you think about when you say for each, you're not saying it's going to go from beginning to end. Now, in C++ it does, just FYI. But in other languages, for each does not necessarily mean that it's going in order. It just means that for each of them, you're going to do something with it, which does allow you to eventually take advantage of multi-core in certain situations. Just want to make sure you're alerted to that. So that's why for each is becoming popular. Hey, look, the find algorithm.
In MATLAB, all four functions are for each.
Yes. Well, for each is more intuitive for non-programmers.
Yeah.
What were we
It's the
doing?
hardest thing for me when I was learning MATLAb.
Oh, yeah. MATLAB. What was I doing? Oh, yeah, find. Hey, vec.bin, vec.end. What number are we going to look for? 71? All right, what do you think this returns? Just take a guess. Wild guess.
An index.
Ooh, good guess. Not quite, but you're on the right track. It's C++, so it's not going to be an index. It's going to be a
Pointer. Sure.
It's not, you're on the right track. It's not going to be a pointer, it's going to be a iterator. There we go. Yep. So this is going to hopefully explode in our face. There, perfect. All right, when it does this, go 2 arrow out.
Wait, what?
No, not 2. Okay, maybe 1. Hold on a second. 2 arrow out. All right. Hey, notice it took all that and didn't print to the screen. 2, I call it arrow. 2 greater than. 2 is your standard error out. 1 greater than by default is what just regular greater than means. Is your standard out. So if you do 2 and the greater, it's going standard error, which is all your error messages going to out. So now we can open up out, and we can at least see that error no matching for operator less than for OStream when trying to apply to a oh my goodness normal vector int blah 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 blah. All right. Anyways, that way you can at least see all the error messages. How many lines were there? 214. Perfect. All right. Well, anyways. So if you want to find out if it does exist, you can put does not equal vec.end. Because if it doesn't find it, then find will return vec.end. If it does find it, then it returns something that's not vec.end. Or it's going to not like that. Oh, I need to put some parentheses. Oops. There we go. 1. 1 is true. And just so this makes sense, if we try and find 20, which is not in there, is 0. And let me go and make this at least easier to read, even though it's already kind of complicated. All right, there we go. Yep, there's 5. It is kind of weird using these functions at first, but if you get good at them, they can be very handy. Other times, that error message is ridiculous. All right, so find you probably just write yourself, but there are some other functions that you get used to doing things this way. It becomes handy. Find if. Should find the first element of V, which might test is true. So you can pass your own function for it to call to test against all your elements to see if something does exist. This is extremely handy when you have a complicated data structure. And by complicated, I mean something besides a basic int, float, or string. And you want to write your own special function for it, or you haven't overloaded the double equals operator, you can write a special one, my test, it's greater than 21, less than 36. Ooh, let's see, which number should I give back? 34. Do they show me running this? No? Okay. Do you want to see this? Yes, no, maybe. Did y'all stay up late last night? Is that what happened? No? No? Okay. What's that? All right, count. Return the number of times the function passes. All right, what's the count? Greater than 14, less than 36. Two. All right. I got 2 as well. Anyone else?
Yeah, I got 2 as well.
Yeah, 17 and 34. Whew. Oh, good. Oh, yeah, that's right. This works differently. One moment.